Okay, let's go through some basics for forces. Now, this will be a quick revision of what we have gone through last week. Now, essentially for forces, you are going to use one basic formula. The tricky part will be to decide how you want to interpret the question and identify the various forces at work. So formula-wise, I would say you don't really have much of a choice. So essentially, this is the only formula under forces. Now, the tricky part, or I would say one thing to really take note of is identify what is your object of interest. That would be its mass. Now, I'm not going to go through the SI units again. So do ensure that you're using SI units for all these parameters in order for this formula to work. Now, likewise, acceleration refers to the object's acceleration. And it goes without saying, you have to be clear. Your question, what is the object of interest in your question? Now, lastly, this formula only works if your force is the net force. So let's say I have this particular object here. It is acted on by a force from left to right and another one from up to down. So let's call this F1 and this F2. Now, technically speaking, you cannot use either F1 or F2 within this formula, right? So the reason is F1 and F2 are not the net force. So in this case, you have to do your drawing, but of course, occasionally you can simply use maths to figure it out using your trigonometry. If you've done it, if you haven't, then you probably have to use a scale drawing. Take your F1. Make sure the length and the direction remain consistent. Then take your F2. Now, again, a reminder, your F2 should follow from the end of F1. Now, once you have done that, you simply join the beginning or the starting point to the ending point between F1 and F2. Now, direction will stay consistent as well. Starting point always points to the ending point. And a reminder, you're supposed to use a double arrow to represent a net force or the resultant force. Use your ruler, measure this length, and if necessary, you may also need to determine its angle, whether it's northeast, southwest, or perhaps you need to measure a particular angle. All right, that aside, once you measure the length, you need to determine what exactly is the magnitude of this net force. And only then you can substitute that net force into this formula here. Now, one last point to add. Your acceleration is a vector, just like net force. And hopefully you can remember enough to tell me that mass is not a vector, this is a scalar. So it means that F net and acceleration should be in the same direction since both of them are vectors. Okay, so keep this in mind. So for this particular case, my acceleration will be in the same direction as the net force. Now, in addition to this formula, yes, I said that you only need to know one formula for forces. In addition, it's quite common to actually involve kinematics with forces, and that particular part is included under acceleration. So it will not be strange to actually use the formula for acceleration together with the formula for force. So do not forget this particular formula, which comes from the chapter of kinematics. Again, I don't think I want to go into detail regarding this particular formula. Just well, an important note. For this formula to work, of course, you need to use SI units. The second condition for this formula to work is acceleration has to be constant. Otherwise, this formula doesn't work. So keep that in mind before you blindly use this acceleration formula. Now, I will include the worksheets in the Telegram group chat. And here I will show them in Miroboard. Now, of course, we are supposed to work out all this, the answers to all these questions, but I'll give you a few hints here and there. Now, if you point your attention to this question 2, now the thing is this, there are two trolleys, X and Y. I want you to be particularly clear when you apply that formula. All right, in this case, they have the acceleration here. So when you're applying this particular formula, which object are you referring to? Okay, and you may have to actually apply the formula 2 times, one for trolley X and another time for trolley Y. So that should not be surprising. But more importantly, look at this link here. Now, anytime you see a link like this, it can be a, well, anything, a bar, metallic bar, it can be a string, a rope. Now, as long as it is taut, it is tense up. There is this tension, Tx, pulling on trolley X. There is also a tension, Ty, within the same spring, or in this case, it's a spring. There is also a tension, Ty, pulling on trolley Y. So it's possible to have these two tensions within the same spring. However, whenever you look at the spring or string or rope, anything that is taut, these two tensions are equal. Right? They have to be equal to maintain the integrity of the spring. So you will need to use this piece of information in order to solve for this question. Now, question 7 is of particular interest as well. It can be quite confusing, but nevertheless, it can be a question that comes up for you. Okay, now here we are looking at the from a microscopic view or a more detailed view. Now, most of the time, we do not think too much about a car. We simply want to know its direction of travel. Let's say from left to right. So that is the movement, direction of movement. Now, in general, the friction will be acting in the opposite direction. That is what we typically visualize in our forces diagram. But I want you to pay attention to this particular question here, question 7. It's not exactly looking at car as a whole. It's looking at the tire. Now, this becomes a more detailed perspective because your tire is actually turning. All right, so think about it. It is actually turning. So how is the motion of the tire like? Let's assume the car is still moving from left to right. Now, if you think carefully, you realize that the point at which your tire comes into contact with the ground tells you this tire is actually moving from right to left. So that is the direction of movement of the tire at the point in contact with the ground. So think about the answer from this perspective here. Now, this is an open-ended or structural question. Now, without looking, without analyzing the whole question for you, I would like you to focus on a few highlights here. The question tells you that the girl is accelerating upwards. Now, I think in this particular question, it's rather obvious you are interested in the girl. So as I said, it always makes good sense to identify the object of interest. And in this case, it's the girl. Now, in addition, the question also mentions that the girl is accelerating upwards. Now, of course, in this case, by upwards, we infer that it's vertically upwards, right? So she is accelerating vertically upwards. Now, what else can we infer from this? It also implies that your net force is in the same direction as the acceleration, and there is a net force. For the simple reason, my acceleration is not 0. Okay, there is a net force, and this net force is in the same direction upwards as the acceleration. So try to take all these clues into consideration. Now, again, here they mention an angle as well between the elastic ropes. So in this case, the angle will be this 60 degrees. Now, I will leave you here to further work out this question on your own. And in fact, they have provided a scale diagram for you already. Now, likewise, if you look at question 2, I hope you are very clear when they use the term accelerates at a constant rate. Now, that should tell you your acceleration is constant. And once you know that, in your head, you should realize that your acceleration formula can be used here. Now, I'm not saying that it should be used, just that it can be used, and it's an option that you may want to consider. Now we have another question here about the average mass, average accelerating force. In question 3, you may want to think about this word average. Why do they even want to include the word average there? Okay, I'm not going to tell you the answer right now. Think about this. Why do they have the word average? Well, it may or may not affect your answer, but it'd be good to think about this. Okay, likewise, you see the word average again, right before accelerating force. Why do they have the word average there? Now, I shall give you a hint. Now, essentially, if you ever see the word average, it means that whatever factor it is describing is actually changing with time, or at least changing. But of course, in this case, it's changing with time. And I also want you to think further, if you can, why is these two factors changing with time? Why is mass changing with time? Why is accelerating force changing with time? Now, likewise, they add words like minimum. Why do they need to include this word minimum? Can't they just leave it out? Now, of course, this may or may not affect your answer, but it's always good to think about this extra words in your question. Most of the time, in fact, I would say all the time, they imply something. They imply certain assumptions, right? So if you can figure out what that assumption is. All right, again, question 4, you see accelerates uniformly. Well, without repeating too much, again, I hope you realize your English at least should be good enough to help you realize that this means acceleration is constant. And of course, that means you can use your acceleration formula here, if you need to do so. Now, I would tell you one last thing. This is a very important hint. Now, this is a bit different from, let's say, the words average or minimum, where in which they are not so, they do not affect your answer that much, but this does. Anytime you see constant speed, right, sit up and take notice. Constant speed tells you something very important, right? But what does it tell you? I hope you remember constant speed. Do you remember? Now, essentially, if you go back to kinematics, it means acceleration is 0. And if you make use of this formula, but before I go further, there are lots of people who write this formula in this manner. Now, this is not wrong. However, I prefer to write with the net as a subscript because it reminds you that the force must be a net force. Otherwise, this formula is not usable. So if you want to use this particular shorter version, you are, I mean, it's fine as long as you take note that this is a net force. Now, as I said, based on this formula, since acceleration is 0, net force should be 0 too. Okay, so see whether you can make use of these hints. Now, that is about all I want to tell you. Let me see. Oh, there's something else here. Now, likewise, this is the last question for the worksheet. Again, be very sensitive to words like this, held in position. All right. So once you see this phrase, it simply means your object is stationary. It's not moving at all. And therefore, that should imply that net force is 0. Or the other word that I used previously is all forces are in equilibrium. Now, lastly, when all forces are in equilibrium, this also implies that if you try to draw a scale diagram, joining all the forces together, you will end up at the same starting point. So these are existing forces. None of them is a resultant force. Take notice I didn't draw any double arrow. Every single force is a single arrow. So they start and end at the same point. And that means they are at equilibrium. And that also means there's no net force, or net force equals to 0. Yes, I believe that's all I have to tell you for now. So it would be great if you work out the answers to these questions. Now, of course, if you're short of time, at least attempt the MCQs given in this worksheet. So I shall see you in the following week to go through these answers.